Hello, in this video I'm going to show you how you can implement the defect heat map based on external actions in Plotly, the plotting library of Python. Why would you need a defect heat map? You would need to identify, maybe for a release, and all the open defect, where the heat lies. So if you have a lot of defects in the area of high severity and high priority, this will help you to analyze exactly what the current health of your release is and what the heat maps for a release looks like. So this feature, as all the external action features, will take the current filter, which is applied in ALM Octane, to generate such a chart and a plot. So first of all, here now I can filter for a release. And I'm maybe only interested in the opened defect and maybe also the new defects. I want to focus on the rest, the ones which are fixed or proposed close, I don't care. So this is my focus, and now I can select here all the defects I have. So in total I have 133. And let's create a defect heat map. This is based on external actions. So let's say accept. And now you can see here a chart which is generated, a plot, which shows you here the S0 to S5 axis, as well as P0 to P5. And the P stands for priority system field of Octane, and S stands for severity. Wherever you have not provided severity or priority, it's unknown. So all those defects are categorized here. Maybe it's also good to know if you have defects in this area, so you can focus and apply exactly what is the priority and severity. If you don't want to miss something. And now here, this is the area where you want to focus on. So very high to urgent priority and high to critical severity, because these are the defects where I will struggle if I don't fix them during a release. So here I can see this is the total summary, and for this release the heat is quite high. And so I can see I have urgent and critical defects, which are number 11, and also still very high severity defects for urgent priority, 19 defects, and still here, which I really, it's not so much high, but you will require your focus. So you can use this heat map to exactly identify where your heat lies in ALM Octane. Now coming back, you can also change the filter. Let's say I keep the open and new, but I would like to see it for Q1. So there I have no defects. So let's see here, what's the heat for Q2? It makes no sense here, but still I will show you because I have not enough defects. But let's generate the defect heat map. And you can see here I have not much heat. So we have 6 defects and they are around here. So you can see them directly in this area. But now let's see how you can implement this graph into your ALM Octane solution. Again, we come back to this Python repository, where you will find under external actions, you will find the code which I will just commit. And so you will find a code for defect reporting. Under defect reporting folder, you have here the defect reporting itself, where you just need to copy this function and apply, you need to change the client ID and the client secret for your environment, and also make sure that your Flask is running on on the IP which is used by your Flask server. And then you can use this external action and copy it directly using the Flask server IP you use basically for where your Flask is running, and all these services will be available. We'll just copy this into ALM Octane's external action editor, and it will provide you a button here which will make sure that this feature is available for you.